Hey everyone. Today I want to take a different step towards our understanding of computers. And I went ahead and created a simple little 3D setup, kind of simulating what is our perspective of memory versus what the computer sees in memory. So, before I've said that computers are really stupid and humans are smart. And that's really true. So, um, memory is laid out really kind of however we as developers decide um, to imagine memory. So, I mean, at its basic, memory has two elements. It's got an address in memory. So, over here, we've got our location, the same way that you would have a mailbox. So, here we have location 0, and in location 0 of our memory, I'm going to go ahead and scroll in location 0, or at address 0, we've got a monkey head. At address 1, we've got a torus. At address 2, we've got a cone, and address 3, we've got a circle, or a sphere. So, this is our perspective of memory. We have different sets of data. Think of all of these things as data in memory at the address that it's represented. Well, we're smart. We know that this is a monkey. We know that this is a torus. We know that this is a cone, and we know that this is a circle. So how would the computer see this? Computer sees this just like this. This is the address. This is data. This is the address. This is data. This is the address. This is data. This is the address, and this is data. So all it really sees is a sequence of numbers or data at a specific address. So we have to give it. It's really agnostic. It doesn't really know what to do with this data until we tell it what the data should look like. So, as programmers, we have to figure out how the computer should interpret this thing as a monkey, this thing as a torus, this thing as a cone, and this thing as a circle or as a sphere. We have to give it instructions on what to do. So we could say, for instance, that this monkey up here is, I'm going to go ahead and add some text. Actually, oh crap, wrong thing. Ignore that. So let me just go ahead and just copy this over here. Control DX, move it over. So let's say that this monkey head is actually, let's call this thing integer. So that'll be our integer. We can say that this thing is, I don't know, I'm going to not be creative, and I'm just going to control, come on, there we go, control D, X. I'm shifting that thing, X. Why is it not moving? There we go. Okay, so I'm going to call this thing over here an add of whatever it might be. So blah, blah, blah. Add something. This one over here, I'm going to just actually call as, I'm going to create another little thing over here. Let's go ahead and move this over here. And in this instruction, I'm just going to say that this is, actually, instead of even doing text, no, I will do text. I will do text. I've got this. Let's edit. I'm going to say that this is actually OX3, for instance. And I'm going to go ahead and delete this thing and not use it. And then I'm just going to shift this and put this value inside here. So suppose that we just want to have the value 3 for an integer. Well, I already said that a monkey is an integer, so let me go ahead and change that. So monkey is going to be like, I'll say that monkey is now add, blah, blah, and then this one over here is going to be load. Load next. Address at next. So, and then this thing over here, and that'll be like our instruction. And this thing over here is just going to be like, I'll just go ahead and say it over here. Let's shift D, let's move it over to this part, and then I'm going to go ahead and change this, and I'm just going to say that this is a sphere, because that's what it is, and that's what we want it to be. So, if we were processing this thing, as far as the computer is concerned, it'll do whatever it can in address 0. It's going to say that it's going to add. So it'll get the add instruction, It'll do its addition and load it into whatever its registers are. Then it'll go on to the next instruction, which will be 1. And what does it see in 1? Oh, we've given it the one term that it knows. It's going to load address at next. So, and it's going to treat this thing as data, for example. So it's going to load whatever's in here. It's going to load whatever's in 2 and treat it as an address. And then it's, so we've got this thing, we've got the value 3 here. And suppose we added another load in between here, instead of having that thing as load as next, it would say it was like load at, whatever this value would be, then it's going to load the sphere. So that's one way of looking at memory. We have our perspective of whatever the thing is. We've got a monkey. We give the computer example of what the monkey is. We have a ring. We tell it what the ring means. We have our numbers, which can just be constants or anything that we want. And then we have just generic raw data. And this raw data might have multiple meanings on top of it. So I'm going to go ahead and take this thing and let's just go one step further. I'm going to go ahead and apply that. And then I'm going to add another modifier, array, and then now I've got a count 2, offset, and then z is going to be minus. So I'm going to go ahead and create more memory stuff down here. So we've got our other sets of data, and we can go ahead and keep adding in new values for this. And other sets, I'm just going to go ahead and not be creative and say we've got another sphere and another sphere and another sphere here. And these spheres each mean something in some way, shape, or form that might be assigned to our projects. So like this could be a set of names, or this could be a set of IDs, or it really just depends on what you want to say it. And like this one, for instance, this could be like unique ID 1, and then let me go ahead and give it another color on this one. And oh, whoops, I don't want that. Give it a unique. That one's going to be a blue. And then we've got a sequence of greens and then a sequence of our blue ones. Come on, where's the blue? There we go. So we've got green, blue, and we can keep going on and on and on. So now we can actually treat this little set right here as a group. So let me go ahead and just add a plane. RY90. Where is that plane? There we go. Here's my plane. So I'm just going to expand this thing. S and then Y. Whoops, sorry. SZ. So let's go ahead and just group these two things. SZ. Let me just bring it down a little bit. So that is one group of data that we want to process together. And we want to treat it as like a structure of data. And let's go again and say that this is another structure of our data. And we can go on and on and on and label these things. So this address over here would be 4, and then this address would be 5, and then this address down here would be 6. So as far as I'm concerned, this thing is now our collection of data that we want to process. Again, the processor over here is just going to see 0, 1, 2, 3. This is how I actually made it before. I just went ahead, copied the thing over. Let me move that out of the way. Computer's perspective. Shift D. This will be our address 5. And then Shift D. This will be our address 6. And then finally we have our last address down below, which is our address 7. So it doesn't know that we've created a structure here and we're just treating this thing as a structure. That's why when we program it, we'll set that these things are our structures. So we'll probably do something like load this and load that into our registers, and we'll do something with it. Actually, let me go ahead. Let's simulate as if I was going to be loading this structure of data over here. So I'm going to go ahead and take this thing that I've got of all my circles, and I'm going to create another set over here. Instead of calling this as memory, for instance, I'm going to move it over, make it a little bit wider so it looks different, And then I'm going to come up here and I'm going to call this, instead of addresses or standard memory, this will be our registers that we want to operate on. And then this thing over here, the whole thing together is going to be memory. So suppose that we want to operate on this struct. So what would we do? If we have our registers over here, let me go ahead and label these things R0, and then I wish that I could programmatically do this. I just haven't had time to set it up and do it, so I'm going to manually do it real fast and quickly, so it's not going to look super pretty. R1, R2, R3, R4, R5, R6, and then finally our R7. So what are we doing in these registers over here? Like, I'm going to go ahead and just select all these things and make it so we'll have our... well, I can't really do our programmer view there. It won't be clear. Or the computer view. So I'm just going to have them deselected, and we'll just do it this way. So if we want to have our structs here, suppose that we want to take this structure and load it into our registers. Ignoring these instructions, they don't really mean anything. So I'm just going to say, like, ignore all this for now and just say we have one instruction here, which is going to load a sphere. So let's rename whatever these instructions might be for whatever reason. Let's just say load sphere, or load value. Let me just say load R0 equals, and then data at sphere, or data at OX3. So that's clear, right? We're going to put R0 equals, we're going to basically load R0 with whatever data is at 3. In this case, it's our sphere. So I'm going to take our sphere, I'm going to copy it over into R0, and then now we can have our next instruction. And let's say I want to have another monkey do, monkeys are going to be our loads. So we've got our monkey here, and this monkey might have a different actual like set of values. So in this case, it'll be load R1 with data at OX4 in the simplest case. So we're going to take this and I'm going to load it into R1, and then we can process it however we want. So these loads, for instance, right now I am directly accessing memory given an address. So I'm feeding it a known address for this value. But suppose over here, instead of having this OX4, I had before OX3, and I had a list of these values that I wanted to read, and then let me go ahead and copy this one down here, and then OX7. And then in this case, I have another set of values that I want. So OX3 is going to be our offset. I'm just going to write OX3 here again, and then this one is going to be it's going to be empty, really. So I'll just go ahead and delete that. So this is a lot of how you might actually see your LC3 code. Down here at this known address, relative offset, you might see, when you're programming it, a label. So over here, we can label this as, I'm just going to say data address. Or data start address, to make it a little bit clearer. So we've got our data start address. And then over here, I'm going to go ahead and move these monkeys down by 1 to make it a little bit easier. Then I can move that down and move that down. And I'm going to go into the next type of addressing that we have available. So let's add something over here. I'm going to go back to my handy dandy cone, make it small enough to actually fit in there. And then we'll say now that for whatever reason, this cone is load and I'm going to go ahead and put it as R2 equals data at OX7. Because these spheres might be somewhere different. We might actually have data that's really far away. And I'll get to that in a point. So R2 here on this instruction is going to be equal to OX3. And then now, instead of having this thing at OX3, load R0 equals data at, and then R2. So what are we doing now? We're loading, we're getting the value of data given an address that's saved in one of our registers. So what the processor will do is it'll say, okay, we've got an address in here, which we've decided to say that this is actually an address as a programmer. So treat R2 as the data in R2 as an address, and then load R0 with the data at that address. So it's going to go over here and it's going to load the sphere. And then now what we can do is, sorry, one sec, my cat just tried to jump onto my lap and fell and broke something. Here, give me one moment. Okay, so I'm back. So before I was saying that we could load our data with a value, with an address that's saved in R2. Well, we can also do an offset address from that. So R2 plus 1. So that's going to load our R1 with, it's going to go here, it's going to go offset by 1 on its address, and it's going to load this value over to here. So let's go through this sequence really fast. I'm going to delete this, delete this, delete this. So when the processor loads, it's going to say, okay, I know what this instruction is. I'm going to take this thing, I'm going to load it as an instruction. Okay, we found our cone. We don't know what a cone is, but we know that this cone means load R2 at with the data at 7. So let's go ahead and take this. We're going to load it into R2. But we don't know that this is an address yet until we get to this instruction. So we're going to use R2 as an address. So load R0 equals the data at R2. Well, R2 is an address. We'll go over, we realize that it's 3, so we'll load it into our processor. We know that we'll go to this address, and we'll take this data and copy it into R0. And then we'll do something with it. And then we have our R1 over here. We'll go to the next line. So load R1 equals the data at R2 plus 1. So we'll take this, we'll increment it by 1, and we'll get the data at that address. So over here, we basically just take that and put it here. And we can keep adding new instructions as well. So in this case, I did load R1 equals data at R2, but suppose I wanted to, instead of load R1 with the data at R2, I can say store, instead of having R1 here, I'm going to say R, oh man, this is going to be hard because I want to have another instruction here to do something cool. But I can say store R, store R0 into the data at R2 plus 1. This is a little bit confusing, but bear with me. So we no longer have this thing. If we go through here, we would have the sphere getting loaded, or the address getting loaded first. We'd load this sphere, and it would get to this point. And now we get to this instruction, and it's saying, okay, we've got R0, we have this address, let's increment this address by 1, go to that location, and then put this value in there. So that's what we'll do. This value is going to be overwritten with this sphere. Our perspective. And I kind of butchered that by making up some instructions as I went. But hopefully you guys get the idea that the computer knows some basic instructions. It knows how to load, store, add, shift, and so on. And that is in the ISA. Those are the instructions that the computer architecture allows for our programs to run, because it's what it truly understands. As far as the data that's in memory, other than these instructions, it's up to us to decide. So we've decided that these things are going to be actually treated as instructions, even though we might actually have the exact same value in data down here in this thing. So we may have a monkey down here. Up here it means store, but down here it just means whatever the value of a monkey is, whatever that may be. And we get to, again, as programmers, we decide what these values mean.